My name is John Pedersen. I'm the CTO at Midco, and Midco is a company whose territory is in the Dakotas and Minnesota. Basically states that end in OTA. And so we're right in the middle of farm country, so this topic is near and dear to me and to some of the things we're doing. So I'm anxious to hear what our panelists have to say. The description reads, smart farms utilize new tools to develop more efficient operations and management and to assist in the decision-making process to improve productivity. Charter will demonstrate how the synergies between C-band and unlicensed spectrum can enable a smart farm vertical for massive connectivity in conjunction with IoT devices. Next, Comcast will present on how any IoT application relies on data generated by sensors that are part of the ecosystem. The presentation will look at how high-fidelity sensing could be achieved with existing or new hardware and software solutions. Our first speaker is going to be Elliott Hoole, who is Director of Communications Wireless R&D at Charter. And Elliott's profile reads, Global Leader and Innovator in Wireless Technology. Elliott?
Thank you. Thank you. That's the profile you get when you don't upload a bio. So I do work at Charter Communications in the wireless R&D group and the 5G team. So at Charter, we've done quite a bit of testing in various bands, wireless bands that are up and coming ones. So we've done some 28 gig testing, we've done some 37 gig testing, we've done a few other bands. We wanted to do some testing in, how about if I get started here? Sorry, I can actually start the presentation. Okay, so we were planning to do a trial in the C-band. We wanted to try some mid-band spectrum, and we didn't want to do just the same old testing that we'd done in some of these other bands. And so we thought, well, what if we kind of apply this with a tool that the people that are going to use this broadband spectrum can help them with what they're doing. So the big push, the primary tenet of this was rural broadband, but then on top of that, we built a platform to collect data and provide a tool for the farmers who would be using this spectrum. So we went to an actual farm outside of Cedar Rapids, Iowa, Keystone. It's a family-owned farm. The guy that runs it is a fifth-generation farmer on this property. It's about 250 acres. He does both corn and soybeans. And then associated with this farm are also an additional 4 hog houses where they have about 10,000 head of hogs. So the project was to really come up with IoT sensors and deploy them intelligently so that the farmer has access to data in both the fields, the grain bins, as well as the hog houses as well. So we used a C-band link as kind of the broadband backbone of this. But in addition to the C-band connection, we employed unlicensed technologies using LoRa, 5 gigahertz Wi-Fi as kind of a point-to-point link to some of these hog houses, and as well as 60 gigahertz as a short-distance high-speed link to connect everything together. So as you can see kind of at the top there, there's a bunch of LoRa devices, motion detectors, soil monitors in the fields, temperature sensors in the grain bins, door monitors in various places, even a location tracker that they put on the tractor, and you can actually track it in real time as it's driving around the field. That's pretty cool. A pump monitor, so there was a well pump about 2 kilometers from the house where we could monitor the pump activating and deactivating. And this all came back to the LoRa gateway, which then fed into the C-band link out to the internet at large. All this data was collected in a LoRa application server. That part was really managed by a partner of ours who worked the warehousing and collection of the data, the presentation and analytics, so that one interface, you could actually use a web-based portal to look at the data that was collected. And in addition to that, on top of that, then another partner helped with some visualization. So in the right-hand corner there, you see a tablet application, and that's actually a real application that was developed. You could see it downstairs in the exhibition hall. Any of you are welcome to stop by and see that. So I even showed it to John, so he knows it works, it exists. So that tablet application is one interface. And then if you look on the left of the barn there, there's actually a VR headset, and there's a VR interface as well. So you put on the goggles, and you can basically look like you're on the farm. You can look around. It's a 360-degree image that was captured, and then the readings are superimposed on that image. So all of this was done over the course of about 6 months on this farm. Oh, I guess video monitoring of the hog houses as well. At the bottom, there's a Wi-Fi point-to-point series of equipment that goes to each of the hog houses, and then you can see live stream video of the animals in the various hog houses, so you can monitor them. And this was all done with the cooperation and help of the farmer, what sorts of tools and things that he need to help him do his job. So this was all built for a real application. So the C-band link was one, like I said, the primary tenets of this trial. So we used 100 megahertz of spectrum from 3700 to 3800. It was really using prototype equipment. So you see there that the throughputs that we measured were still well below what we feel is achievable. So the gray box shows 429 megabits that we actually measured at that location, but the software that was used was not really productized at that point. And so the engineers felt that they could get at that location something along the lines of 1100 megabits once they fully got the software up to full feature set. So over a 2 kilometer distance, we can achieve, more than a megabit. And this was not an unusual case. There was actually one where it was 4.5 kilometers away, and that we felt we can get about 850 megabits or so with the product software. So rural broadband using mid-band spectrum is thoroughly achievable in some of these kind of deployment scenarios. And once you have the broadband connection, there's other things you can do. Obviously, IoT is one of them. We actually tested desktop as a service across that link as well. We had just a thin client connected to a mouse and keyboard and monitor. And so providing computing sorts of environment for people that don't necessarily have computers or don't want to maintain computers, but can have access to powerful experiences like a desktop as a service. So for the IoT connectivity, as I said, we used LoRa for most of the sensors that we used. We deployed about 70 sensors in various locations. We used temperature, humidity, door monitoring, so on-off sensors, window shades, fans, so looking at the presence of power and non-power motion detectors. And those were put into the various buildings around. What you see in the middle of the screen there are grain bins. So that contained quite a few sensors. We actually used multiple in each grain bin just to kind of get a feel for how things changed inside. The farmer actually wanted it that way because if you put the sensor on the sort of outside wall of the bin, you get a different reading than if you put it inside the grain, and you get a different reading at the top of the bin versus the bottom of the bin. So we deployed a few of them just to sort of see how things changed inside the bin and to be able to monitor that. He also had a blower and heater unit in one of the bins, so we could monitor that on and off. So if he saw that the humidity was getting too high, he could turn the blower on. If he needed to dry it out, he could turn the heater on, etc. So one of the things about the system we used, even though we collected all this data, unfortunately it was still kind of a prototype platform, so that we could set thresholds and get alerts from sensors that were out of whatever ranges that were determined. But we didn't have the ability at this point to close the loop and activate something, which of course would be something that would be, very useful in this. And at this point now, there's no reason that can't be done. But unfortunately, at the time of this trial, that wasn't possible. But that's certainly something that this system would be fully capable to do going forward, which then you can just activate the blower, you could activate the heater, turn it on and off automatically. So that's all possible now with this system. Field sensors, we put moisture sensors in each of the fields around the farm at various soil depths, so the farmer could monitor those, the moisture at those levels. Security, we used surveillance cameras inside the hog houses, as well as temperature and humidity and other environments, so that one of the things that we were doing basically for the farmer was helping save labor costs. So if the farmer didn't have to go, this was a way for him to sort of prioritize his activities, right? So he could look on a dashboard and see what alerts or what issues there were, and then sort of prioritize his activities and not just have to randomly go around and see if there were any problems or not. He could address the things he knew he needed to do. So here's a screenshot of the temperature sensors in the grain bins. You can see there's multiple ones inside. Those little triangles show that the alerts are active. So the temperature is out of bounds, looks like it's probably too low in this case. But you can look on each of the grain bins and see what the status is, as well as the humidity. There are 5 grain bins total, as well as 4 fields where there were sensors deployed as well. Here's a screenshot of the hog houses. So you can see there's temperature, humidity, CO2. That was something that was kind of interesting to see whether that, how that changed over time. We got barometric pressure kind of for free, but I suppose you could tie that into weather observations, and if you knew a storm was coming, maybe you needed to go and batten down the windows or something before that hit. So just giving the farmer more information to use to help him plan his activities. So opportunities we think are pretty interesting here. The farmer that we worked with loved this. He didn't want us to decommission it. We still haven't yet. It's still active on his farm. And we think something like this would help many people like him. He's, like I said, a small farmer. 250 acres in this day and age is a very small farm. And so one thing he needs is tools to help him. He's competing against farms that are 10, maybe even 100 times bigger than he is. So he has to be as efficient as he can be and use all the tools at his disposal. So something like this is almost critical for the small farmer to be able to maintain his competitiveness. Another thing to mention is a drone system that we hooked up with this. So the idea is you fly the drone. You can either set waypoints to various places, or you can fly it manually. So if the farmer didn't want to actually go or have time to go someplace, he can send a drone, launch the drone over to see what the problem is. The drone will show the video to the farmer right on the application or the VR headset, and then he can plan according to that. So the drone can fly out and back automatically and give the farmer some idea of what he's seeing or what's going on out there. according to the USDA, farms like this represent about 22% of the farms in the country. So we just sort of addressed a small part of the overall market, and just the hog and farm, or sorry, the seed and hog farms, according to the USDA, generate 154 billion. So, you know, that's only 20% of the overall pie. So, coming up with effective business models for this can be quite lucrative, and that's something Charter's looking at, putting together something, an offering. And so I mentioned the platform that we used for this. It's a generic, I'd call it, or a multi-purpose is probably a better way to put it, so that it's not specifically geared toward agriculture. It could be used for smart industries, smart cities, any variety of IoT-based sorts of applications. So it's not just about farming, it's about scale. So once this application is launched, it can be used for many other things in a similar sort of vein. Okay, I think that's about all I had at this point. So thank you.
Thank you, Elliott. Our next speaker is Mr. Arun Ravisankar. Arun is a senior systems engineer at Comcast Labs. He holds 14 years' experience with set-top boxes and digital TV technologies, having worked extensively on broadcast standards like ATC, ATSC, DVB, MPEG, and the RDK software stack. He's also been hands-on with many advanced AV formats and the WebRTC protocols. Working on IoT standards and using IoT for activity monitoring and researching RF technologies designed for human activity monitoring. A self-described Linux freak, Arun never tires of learning new tips and tricks about operating systems. He's a great fan of embedded programming and says he's found new love in the emergence of IoT and machine learning landscapes.
Thanks, John, for reading the bio verbatim. And so, hi. We have a very good mix of rural connectivity and IoT for residential applications as topic here. So, what we will be looking at here is how we can bring about new sensing techniques for IoT-based applications, how new sensing techniques will improve or bring about high-fidelity data into the system that can be used for providing enhanced applications and peace of mind to the customers. So jumping right in, so these are basic aspects of any IoT applications. They include, specifically we are limiting here to residential applications, so be it home automation or security applications or health and wellness application. The primary goal is to bring peace of mind and provide a worry-free experience to the customers. So connected health applications provide greater detail into a person's health and well-being, and a major part of all these applications is being played by these tiny little sensors that collect vital data and provide these data to applications that process them. So the choices of sensors, the positioning of the sensors, and using the right mix of sensors and driven by a specific use cases will define a complete product and what they offer to the customers. So any typical IoT applications will consist of sensors, rules, and algorithms. Sensors are responsible. They are the first primary contact with the external world, and they provide vital information. They often convert physical aspects into electrical pulses or signals that can be interpreted by a machine, and rules are specifically defined as to what actions take place when some sensor sends some data, and algorithms are basically computer programs or algorithms that run on top of these sensors. They churn in all the data, and the algorithms chew upon all that data, provide a data analytic framework, and provide insights into the applications. So algorithms play a vital role in bringing in all the AI, ML components into these applications that will provide very good predictive analytics and very highly sophisticated Internet of Things system. So sensors typically used in any of these applications include a motion sensor, door sensors, which are basically triggered by using magnetic fields, and then smoke detectors and video cameras. So, and also for catastrophe sensors like fires or carbon monoxide sensors or any weather-related dangers. So these are typically used in current IoT applications. What we'll be looking at in this session is a new brand of sensors that could be introduced in these area of applications that will bring in high fidelity of information and provide better service, and while limiting maintenance efforts and operational efficiency as well. So all these sensors basically thrive upon communication networks, be it Bluetooth or Zigbee or Wi-Fi or low-powered WAN, and these are the basic area of communications that include cloud-based applications, that include edge applications, and this basically is a picture depicting the area of coverage or how these sensors work together to give a specific application its shape. So, for example, say there is a rule that is set that whenever a front door sensor is activated, a camera will turn on and look at it, and then there will be an algorithm that will trigger an image detection or facial detection, and then the rules will determine the further course of action. So this picture is basically to showcase all the components that was in the earlier slide as rules, sensors, and algorithms all working in tandem to provide a user experience or the applications to the end user. So jumping into the new range of sensors or new brand of sensors that we can look at, one of the promising area is RF-based sensing. So we have been seeing radars in use in avionics and militaries, in any traffic management applications, where it basically depends on a wave that is being reflected by an object, and the reflected wave will result in what we call as a Doppler signature, and that will actually determine the size, velocity of the object and the direction of movement as well. So the same can be applied to residential IoT applications, where we could very accurately predict motion artifacts of a person, distinguish a person from an object, distinguish a person from a pet, and based on their Doppler signatures, and these characterizes the specific Doppler signatures. So it works in the same fashion. A wave is transmitted, it hits the object and reflects back. The reflection will generate a Doppler, and the Doppler signature will determine whether the person is walking, the person is still, the person is breathing, how the person is breathing. So these can be applied to a wide variety of applications ranging from home security till healthcare till home automation. And from home automation, it can use, the radar signatures can be used for gestures, maybe hand gestures or finger gestures. So if you look at this, these are the various radar signatures. The top signature is for walking, where you can see a sinusoidal pattern, that those are the motions of the arm, the legs, and the body. So the highest velocity is actually generated by the motion of arms and legs. That's the farthest deviation in the first picture. And also you can see if we can clearly see the distinction between a walking and a crawling, and also a fall signature as well. So the added advantage of these type of sensors is they can penetrate any physical wall boundaries, and they can cover multiple rooms with a single sensor. So these are the advantages of using RF-based, radar-based sensors. So this is a typical application that we could use, where we could use as a single access point, or we could fuse multiple access points or multiple radios together to provide about presence detection, fall detection, motion detection, and also gesture-based home automation for remote man-machine interfaces, advanced man-machine interfaces as well. So Wi-Fi as RF sensor. So the examples in the previous sensor that you looked at was basically from a sensor of 24 gigahertz center frequency. We know that Wi-Fi systems use 5 gigahertz, and the Wi-Fi 6 AX platform also include ultra-wideband of 6 gigahertz center frequency, which will give us much more better fidelity and also much better bandwidth. So looking at AX system, these also have the ability of providing Doppler signatures similar to a traditional radar system, and with the smart use of antennas and MIMO systems, we can actually dynamically switch between applications, whether we want to use the antennas for a Wi-Fi communications application, or we wanted to share the antennas between a sensing application and a Wi-Fi communication application. So these are possible now, and this is an example of how the signatures look. So the picture on the bottom is basically a walking signature for a 24 gigahertz system, and the picture on the top is from a Wi-Fi AC system or an AX system that provides Doppler return path. So you see that the images are flipped, because in the Wi-Fi example, the person was walking towards the radar and then walking away from it. And in the 24 gigahertz example, it's the other way. So that's why the images are flipped. But most of the information is conveyed through the major components inside the Doppler signature. And although the 24 gigahertz has much more finer detail because of the frequencies and higher number of Doppler and range bins that we can find in 24 gigahertz, and the bandwidth as well. But the point is, they exhibit a similar pattern, and we could use this pattern to detect presence, detect motion, and provide home security or health and wellness based application using these systems. So the other sensing technique that we could actually look at is audio-based sensing as well, using ambient audio for detecting glass breaking or fire alarms or any kind of audio sensing. So this is again going back to the frequency domain, where we actually analyze the audio samples in frequency domain and use machine learning algorithms to categorize audio signals into various types, and then use inferencing to determine what exactly is the cause. So glass breaking has a specific spectrum in the frequency domain, training the algorithms, and then using various machine learning methods to use ambient audio and basic microphone sensors to determine if there is a door opening or glass breaking or call for help or baby crying or gunshot or fire alarms or whatever we could think of. So this could be another sensor inside the home. So we have microphones all over the place in cameras, and so although they have their privacy concerns, but these are the features that we could use from an audio-based sensing system. So the other sensing technique is basically using machine vision and cameras. So even these systems have very high privacy concern, but with the combination of edge compute and machine learning algorithms, we could actually bring all the inferencing down to the edge so that no privacy critical data is sent up to some server or some cloud, and all the detection can be done in the premise or on the device. So we could train using OpenCV and machine learning models. We can train our algorithms to detect presence of a person, identify a person, learn the person's behavior, and do a predictive model of their health, and also do specific home automation like facial recognition or gestures or sign language reading, and all these applications can be part of the machine learning or predictive analysis or computer vision based applications. So in conclusion, these sensing techniques actually add on to what current sensors we have, and then add it on, and if we bring in these sensors and advanced machine learning methods, the features and the applications they support will actually be manifold. Thank you.
Thanks, gentlemen. We do have a microphone in the middle of the room if there are any questions.
Hi, this is to Elliott. You had a 60 gigahertz, I suppose, radio in use in your system as well.
60 gigahertz?
It was up in one of the slides.
Yeah.
What was that used for? What?
The 60 gigahertz was just a point-to-point connection from really like one hog house to another one. It was just a short distance, high bandwidth. You can think of it as high-speed Wi-Fi. So the Wi-Fi networks kind of went from the main hog house, or the main farmhouse out to a hog house. There were two hog houses that were next to each other. And so the 60 gig was just a convenient way to kind of link those two together.
Okay.
And then another point was where on the main farm complex, there was another kind of short distance, high bandwidth point-to-point link that was used with the 60 gig equipment.
Perfect, thanks. And Arun, just in terms of the in-home video learning and the amount of training data that you'll need to be able to identify, perform face recognition, what kind of compute resource do you expect in the home to perform that function? Given that there are lots of machine learning algorithms out there for detecting cat pictures and stuff like this, and they do consume, from the training perspective, a significant amount of RAM to be able to perform that function.
Right. So from a training perspective, we do need a significant amount of data, and that's why we can actually segregate the training and the inferencing portion out. The training could still be done on a high compute, high a high memory environment, and then models could be downloaded to a much low power, smaller form factor devices where inferencing could happen. And for example, it depends on the applications also. For facial recognition, the training set is not much of the training can be done on the device. But for activity detection and others that you have told, the training data is huge for that.
Okay, thanks.
Any other questions? If not, I have a few. This one's for Elliott. C-band is also used for satellite reception. Are there any interference issues or considerations?
Well, certainly there's going to be considerations. That was one thing that using a farm in Iowa was a convenience for where the nearest satellite receiver was about 30 miles away in Cedar Rapids. So we were able to get a temporary license from the FCC. But yeah, if this is going to go into widespread deployment, then certainly that all has to be taken into account. And there's a lot of activity right now with the C-band Alliance and Charter and other people that are looking at this spectrum and trying to hammer out really a final agreement to how this is all going to be used. But certainly that spectrum is currently used by satellite providers, and so interference considerations, have to be taken into account for anything like this.
Okay, thank you. So a little more philosophical question for either of you. As retail IoT devices emerge and smart ag technology is often driven by ag-oriented companies such as John Deere, what do you see as the role of the cable provider?
Well, I guess from my perspective, I mean, we actually did approach John Deere to see if there was something that they wanted to work with us on about, and for this trial and for anything commercialized in the near future. I mean, Charter is not. Maybe I'm speaking out of turn here, but I don't think we'd be adamant about creating something. It's about deploying a service that people are going to use. So whether we partner with people like John Deere or have to go down our own path, I mean, it's about coming up with services that help the customers in the end. So whether it's something we do ourselves or do with someone else, I think that's going to really speak to how effective it's going to be.
Okay. Good.
Again, like Elliott said, so from a cable operator perspective, it's about the applications that the end consumers that is being fed to the end consumer. So it is not about a particular brand or a particular organization or something like that. So it is about creating a common framework where we could actually have hooks that third parties can come in and place their stuff that we can take it to our customers.
Okay. You have a question?
I'll just audio it out. You repeat it if necessary. That microphone fixes. Question first on the farming side of things. First of all, the farm houses have access to broadband through traditional cable methods, or are they not?
Some do, some don't. This particular one does,
Okay.
but there are many in Charter's footprint that don't. So, right, yeah.
With that in mind, what is the possibility of using the farming equipment as stored and forward? Because it's reduced the range for data gathering, drives faster range, solid, houses, the back lots and all that. And then we don't need real-time connectivity for some of the data gathering.
Certainly not real time. I guess depends on what the frequency would be. If it's if you're only gathering it once a day, I mean certainly something like a soil moisture sensor that would probably work okay. It depends, I think, on the nature of the sensor.
How
But,
much of a challenge is the battery powering
well, these are all battery powered, so certainly it's going to affect the lifetime the more often you transmit. And so these, in this trial, we had transmitting probably a lot more frequently than you would typically. So you would want the battery life to be something between 1 and 2 years, which these devices typically would do. But in this application, they probably were shortened by the fact that we were transmitting more often than we needed to, just to collect more data to look at. Right.
Swinging to the other side, Arun, earlier today we heard a presentation talk about rare and exceptional events, and we used the philosophy of saying you can't train on exceptional events, otherwise you're breaking glass in your home to be able to train on it. That's not realistic. Is it possible to use normal training behavior to train the systems to pick up on abnormal behavior? So if I don't fall typically in my home, and if I see what normal ongoings in the home is, that's sufficient to allow me to detect an abnormal event like a fall or some other type of crime.
Yeah, with respect to both audio and RF-based sensing, it's not custom. So the signatures that are generated are fairly broad and common for most events. So the systems can be trained on existing data or by doing academic research and other aspects. And you're absolutely right. We could use normal data, like we could eliminate all other motion to come at fall, but to have no false positives and other aspects, we certainly need specific aspects that can have 99.999% accuracy to detect anything. So to achieve that level of accuracy, we may need some amount of abnormal data or something like that, but those things are hard to come by, so we could take the system to a certain extent using normal data and then fill in the gaps with efficiency with actual data by research and other aspects.
Go ahead.
So, Arun, if I ask from here,
Yeah, go ahead, just be loud.
since I work for Elliott, the question is, I work with Elliott, the question is for Arun. How much of a problem do you think it is that if I were to presume that you're also an engineer like I am, we presume what applications the customers might want just because we are actually better capable of delivering them. And this is an empathetic question. It's not a knock on what we've done. Sometimes I think that we think something is really valuable and we bring it to the customer and the customer goes, I don't really have a need for that. Fault detection, I completely understand, it is a proven business case, but apart from that, like, do you find that we do less surveying of what people want and just more solution development?
Yeah, I think it is more of a question from a business perspective. So the business of any company will do due diligence in finding out what services or what the products would sell better to a specific demographic or to a specific set of customers, and that would actually usually drive the product development. But from a research perspective, from looking at things as how we could do things in a better fashion or in a more efficient manner, so that is on its own track, right? So you're absolutely right. So the business side of it will actually look at customers' needs. What will if we shell out a product that no one is ready to use it, then it will not be successful. So the products and services that are actually sent out of the product cycle will actually be the first focus would be the needs and aspirations and how we can make customers' life easy. But from the research perspective, we should also think the other way as to what other things that we should look at.
One last question? Yes, sir.
I have a question for Elliott. So similar to what you touched on, did you guys look at the feasibility on the business model for the farm? Does it make sense?
Well, we're R&D, and even though we're R&D, we still did a kind of, I guess, a high-level kind of back-of-the-envelope business model. And, we worked with the farmer to do that. What does this do for you? How does it save you money? All that kind of thing. So based on a, pretty high-level accounting, we did determine that a nominal set of IoT devices bundled with a certain class of service would have a fairly short payback time. So that was our kind of R&D business case that, I'm sure the real product people have much sharper pencils than we do. But we did take a look at it to see, is this just an R&D project, or does this have actual business applications? We didn't want to just have something die on the vine. So we did, yes, go into that sort of detail and determine that we thought that there was a good package that could be put together for this.
Okay, please, one more?
Yeah.
Okay.
Arun, what do you see as the advantage of Wi-Fi versus radar for sensing? You said complementary.
So they could be complementary, and Wi-Fi has a definite advantage because it uses existing infrastructure, and it has proven coverage and range details. So radar is, again, we need new set of hardware, new set of compliances, and that is actually another track on its own. So, but they can complement each other very well for specific, very high fidelity applications. We could use a radar-based module while we use Wi-Fi for presence and motion detection.
I guess we do have more time if there's another question. If not, you've got one there? Yes, sir.
Is it, does it need to be like a communication between the different buildings and stuff like that? Is it required to have a line of sight, or could they, because, like ranching and farming in Montana is a lot different than ranching and farming in other parts.
Yeah. I guess I wouldn't say line of sight is required. A dominant path would probably be a good thing to have. So yeah, if you have a reflection, or if it's just something that's, a good signal that gets through somehow. But as an example, in this example, we did have line of sight, but this 5 gigahertz link from the main farmhouse to one of the hog houses was 4.5 kilometers away. And we were getting like a 98% signal quality on that. Now, if you didn't have line of sight, would that still work? And I guess the answer is maybe, right? So you'd kind of have to see. So line of sight does help you out quite a bit, but when you say, is it absolutely required? And especially with the 60 gig equipment, I can say that scattering is your friend in 60 gigahertz. So as you go up in bandwidth, you actually get, some scattering effects that help you more than hurt you in some cases. So hopefully that's a good long-winded answer to your question.
Okay, please join me in thanking our panelists.